Welcome to our webinar. Today we will talking about how you can make the storage from your customer fast again. I'm Jörg from DataCore, but today I'm not alone. I have Andre from Intel with me, and I think Andre will show us a really great opportunity on Intel hardware side, how you can really make a huge step for your customer if we are talking about performance together with our both products. Before we start, please raise your hand if you can see my screen. So I know that everything is fine, everything is working. Would be really great if I can see a hand and you can see my screen. It seems it's working. And yeah, to some housekeeping before we start. If you have any question, please put it in the chat, and we will not close the webinar before we have answered all of your questions. And the webinar will be recorded, and you will get the link after the webinar, so you can share the webinars with your colleagues. They can't join the webinar. Also, you have the opportunity to get in touch with Andre, Alexei, or me if you have questions to the product. We are open for questions, and we will answer as soon we can. Yeah, short introduction. I'm Jörg. I'm responsible for the growth markets EMEA, what's including Eastern Europe, Austria, and Switzerland. The Austrian guys are really happy to be a part of Eastern Europe, and also since July, it's including Middle East. I'm with DataCore since 2006, but I know the product since 2000, so I have a lot of knowledge about DataCore, and I know the product very well. Alexei, some words about you, please, so that everybody knows.
Yeah, sure.
Who you
Sure.
are.
Well, hello, everyone. Thanks for the opportunity to talk to you. My name is Alexei. I am part of Intel team, which is called Non-Volatile Storage Solutions Group. And basically, I am responsible for business development in European region. And today we are going to talk to you about the new opportunities that the latest technologies from hardware side developed by Intel and software side developed by DataCore brings, to make your storage fast again. So with that, I hand over back to Jörg.
Okay, thank you, Alexei. Yeah, if we are looking on the storage infrastructure, the most device we are writing data are disks. That's not changing. It's not changed, and I believe it will not changing very soon. But also there are a lot of other technology on the market at the moment, and some vendors are talking about better opportunities, faster opportunities. But to be honest, you have to have a really deep view on it to understand what's the difference and what's the benefit and where you have to be careful. And it's the target for today, to give you a little bit more overview what it means to use a disk, to use a flash device, to use another technology. If we are talking about this, you know how a disk is working. It's a mechanic. It's a rotating disk. Everything it's working on mechanic. It's slow data access, but you can put a lot of capacity on disks, and they are, I would say, cheap in the meantime. When I started in the IT industry, they was really expensive, but in the meantime, you got a lot of terabytes for a low price, and that's happened at the moment. And since a while, we are talking about flash, and we are talking about based on memory chips technology, typical as NAND, and you can have fast data access. But I think, Alexei, you can give a little bit more deeper view on this technology, because you are more in this technology than I.
Yeah, well, thanks for that, Jörg. And you are absolutely spot on. The technology landscape is changing, right? Probably 10 years ago, we would not even speak about, some alternative, when it comes to persistent storage. But nowadays, I would say that solid state drives is a very valid alternative. And I bet that many people, among the audience that we are seeing today, actually, have to make some choices, whether they would like to use HDDs or SSDs or DRAM, and this is always the question how you balance the capacity versus cost. And when it comes to NAND technology, again, this is not kind of something brand new. NAND existed for a couple of decades already, in fact, but the technology became mainstream a couple of years back when the first NAND-based SSDs were introduced. And at the very fundamental level, this is different from magnetic drives, of course, simply because at the basic level this is all made of transistors, but this is not the similar type of transistors as we find in the CPUs or DRAM. This is a special transistor which is using the special locking layer, like the insulator, which kind of traps the electronic charge in the gates. And that's why it is possible to store the data for longer periods of time. So it is somewhat an art of how to design these transistors in the right way, because you have to apply certain amount of voltage and also have to play with the thickness of the insulator layer. But at the very basic level, this is electrostatic. Some electrons are trapped in the transistors, and those transistors are basically connected as the string when it comes to NAND technology. And that's why this NAND technology is very suitable for large capacities of data. So that's why you don't really have those mechanical wear out which we typically see with magnetic drives, because there is no need to move the reading head and to rotate the spindles. So that's why it is less susceptible to different kind of vibrations. And obviously since because of the Moore's law, the transistor technology is much more scalable. We actually see the better opportunity for scaling when it comes to capacity, and also this also drives the prices down. And if you see the pricing curve over the last couple of years, it's been dramatic for NAND-based drives. So obviously the technology has certain advantages over HDDs, and I could use myself as an example. I don't have in my home PC, I don't have HDDs anymore. I am completely moved to NAND technology simply because it is more convenient, it is faster, but obviously it has some shortcomings that we will cover later on. Jörg, with that, back over to you.
Thank you, Alexei. It was really a good overview, and now I'm understanding it, how it works too. Okay, but if you look on the market, there are a lot of vendors who are telling you should go to all flash system because everything is much faster. It's not more expensive as an HDD device, and it's taking less energy and space as a normal HDD device. That's what these vendors are telling you, and but I think it's not really the complete truth about it. And I think everybody know it, how these vendors are managing and what is the truth behind this story and what's the reason why they are telling this. And if we are comparing the speed of storage media, what we are seeing here now, it's related to the DRAM. And if we go to the HDDs, we have someone that are optimized on performance. We have someone that are optimized on the capacity you can write on. And the same we have on flash, but it's not capacity, it's talking budget. We have expensive flash and we have less expensive flash, and that's how the different. You can see what's the latency is if you are writing to an HDD or if you're writing to a flash device. It's really huge, and it's comparing to a DRAM. That's what this picture shows, and you can see it's really a big step from the latency, from the performance if you move to a flash device. And as Alexei mentioned, I'm using also a flash device and SSD in my notebook, and it's really fast. It's if you boot the computer, it's like you never turned it off, and it's really the difference you can feel every day on your own device. But also if you go to the infrastructure, to the storage infrastructure, you can see, and the customer who is using the application also can see the difference or can feel the difference, not see, he will feel it, I guess. So, but what it's what you should know about the flash, what's really the challenge, or what these vendors are doing. Most of them flash devices are more expensive as a HDD, and I'm sure you know this. If you order a new notebook again, you see there's a price difference if you have a flash or you have a hard disk in. And what the all flash arrays are doing, they are using permanent deduplication and compression to fits better in the budget of the customer. The flash has limitations on the writes per day, and they have the self-destroying writes, and also writes can get unexpectedly slow. We are talking about write cliffs, and now Alex, I think you can explain a little bit deeper what this write cliffs means, please.
Yeah, sure. Well, first of all, I would like to cover a little bit about limited endurance as well. And the reason behind that is, again, the way how the NAND cell is structured, right? Because when you are basically writing into the NAND transistor, you are applying a certain voltage, and at the basic level, those electrons are actually moving through the insulator. And when you do those writes, all over again, it is essentially, kind of a spark which over time degrades this insulator layer. And that's why obviously, there is certain limited endurance when it comes to writes happening. And this is something that we need to be aware of. And that's why the, key characteristic here is either total petabytes or terabytes written, as we see here, or drive writes per day, basically how much writes the device could sustain within its life cycle. So this is an important consideration. The second consideration, again, it is all caused by the way how the SSD based on NAND flash is designed internally. So when we have the drive, which is which we call fresh out of the box, you actually see the maximum performance. But as soon as the capacity of the drive starts to fill up, the controller actually needs to do some housekeeping. So again, because the NAND drives are accessed at certain granularity, at page and block level, you cannot actually write a single byte, for example. You always write data in chunks. And that's why when the whole capacity is filled, it is necessary to become really smart how you could actually move the data which is filled with unnecessary data. And this is called garbage collection. And that's why the controller actually does very smart things when it comes to making the those NAND chips to wear out evenly. And this is called wear leveling. So that's why there are certain things which are happening on the backgrounds. The data is being constantly shuffled within the NAND drive, and that's why as soon as you fill the whole capacity of the drive, the write speed typically goes down pretty drastically. And there are certain techniques how to avoid that we will be covering later on. But obviously, not any technology is ideal, and it is necessary to take into the account the shortcomings of the NAND flash technology. Jörg, back to you.
Thank you very much for the explanation. I have another question to you. What is your experience with the energy? Do you really see that a flash device needs less energy as a disk, a hard disk?
Oh, yeah, absolutely. There is no motor basically rotating, right?
Okay.
And that's why, at the very fundamental level, again, the voltages that we are talking about are much lower compared to HDDs. And that's why, this might not be a big consideration when you talk about maybe, a single home-based PC. But if we are talking about the data center, like, where big amount of servers are located, and you have couple of drives within each server, so especially in case those are allocated to like, like the storage array, it becomes significant, right? And we see that electricity cost is not actually going down. In fact, from my utility provider, I for the second time in the year, I received the notification that they have to increase prices, and prices are in fact going up. So again, when it comes to data center scale, it could be a considerable amount of money when it comes to utility bill. And that's why this is also an important thing to consider.
Yeah, of course. Thank you. So, and what you have to think about if we are talking about flash devices. First question, how you can integrate it in an existing environment. You normally not start on a green field anymore. There is an existing environment. The customer want to improve the performance. How you can integrate the flash device. Then you ask yourself or your customer what you like to improve. What are the requests? Where are the bottlenecks at the moment? And that's really a challenge. Everybody who is in the storage project, and when you ask your customer what you expected, how many increase you expected, how many IOPS you need, it's normally hard to say for the customer. My experience is they have no idea about it, and that's really a challenge. And then, of course, what will be the total cost? Not only buying flash device, put it in, but you also have to think about the total cost of the project, how you migrate the data on the new flash device, how you can take care that all the data service, storage service are available over the whole environment, and what's happened later, when it's later. That means what will be in the future, what devices we will have in the future, where we will write the data in the future, maybe how I can integrate the cloud in the future. Whatever will come, you have to prepare yourself and all your customers for the future and to thinking about it. And our experience is that typically 10% of data needs 90% of the IOs. That's also a point where you have to be an eye on it. And if the customer is talking to you, hey, I have a problem with performance, I need a full flash array. If you go a little bit deeper in the discussion with your client, I think you will figure out very soon, hey, the customer maybe need another solution as a full flash device, and he can save money. And that's in the situation where we are in at the moment really important. A lot of customers are looking where I can save money, where I can invest to save money in the future. And I think you are all aware what's happened at the moment with infrastructure projects. Every customer is looking, if I have to do the invest, what will be the cost after the invest, how I can reduce my daily costs. And that's the challenge we have at the moment. And that's also an important part. You have to have an eye on it on this project. And later on, you will see a solution for this for sure. What's a typical deployment? We are talking about flash. Yeah, all flash device. That means I replace my existing storage and I put a full flash device behind my application servers, and every data are based on flash. The other, especially if you are looking on hyperconvert environments, each server, each hyperconvert server have a flash device, and he use his own local flash device. That's the other option. And also you can mix it. That means you will have a disk array where some flash in and some disks in, and then you have to use the right tools to put the right data on the right place, or you do it manually. You know exactly that's the data from the database you put there. That's are the three kinds of deployment you have at the moment. And if you see, there's no way from one deployment to the other, or no easy way at all that you can see here. And if you are talking about to integrate fast medias, there are a lot of things you will get, but I think there are also some showstopper or some points who slow down the process, and that's the points with the red. That are the topics with the red points. I don't want to read. You can read by yourself, but that's our really we have to have a deeper eye on it, and we have to understand how I can solve this point and how I can make it easier for my customer also in the future to bypass the red points like data migration, especially if you have to replace data every 3 or 5 years. The price increase, what with the cheaper price, difficult data storage servers. It's not easy to find a way for this, but we have a way for this to fulfill these gaps and have a different approach to the customer and show the customer another way he can use or he can go to solve these problems. And the idea behind is really put the Intel Optane and the software-defined storage from DataCore together. And Optane is not a flash device. That's important to understand. And I think, Alexei, you will give us more details what it's really behind Optane and what's different to a normally flash-based device.
Yeah, thanks, Jörg. That's actually a very good segue. So again, it is quite important to, get the basics right? And when it comes to Optane technology, something that I would like you to go away with is that this is fundamentally different from what we have today. It is different from DRAM technology. It is different from conventional NAND. SSD storage technology is just something new kid on the block, which didn't exist, let's say, a couple of years back, right? And this and on this part, on the right part of the slide, you could actually see what is different, because as I mentioned earlier, the NAND technology and DRAM technology, in fact, as well, are both based on the transistor technology, which has gate and source and drain and stuff like that, and the shortcomings that we discussed earlier. When it comes to Optane, at the very basic cell level, this is completely different. This is actually based on the resistance technology, right? So this is completely different structure, which kind of changed the state. So it doesn't hold the charge, but it changed the state of the cell. And it is also possible to address every single bit individually, unlike NAND. So it is a persistent technology. It is not NAND type flash. This is fundamentally different. This is new revolutionary material, which didn't exist a couple of years back. And that's why, we see tremendous improvements when it comes to basic characteristics. We see the increased performance. We see the much greater endurance because there is no those sparks. There is no wear out. So that's why, this technology is much more reliable. It lasts for longer. Latency is much improved. So those are all benefits associated with Intel Optane memory. And unlike DRAM, which is actually the 2D structure, Intel Optane could actually be scaled, in the 3D manner, so that it improves density much better compared to DRAM technology. Jörg, and if you could go to the next slide, I will cover a little bit more about the specific subset of products that we are focusing on. Important to note here is that Optane is kind of what we call the umbrella brand, right? So you might have heard about Optane when it comes to client PC technology, and you see those devices on the left. Maybe you are interested in gaming or workstations, and there are certain Optane products for that as well. Maybe you've heard of Optane technology packaged in the like DIMM form factor, like in the memory model form factor, something that you see on the right part of the slide, and we call this Optane PMEM or Optane persistent memory. But something that we are focusing with DataCore, that has been center of our collaboration. And Jörg, this is just a perfect timing for animation. Thank you very much. That's the what we call the Intel Optane Data Center SSD. So those are the products which are specifically designed with data center in mind. And the idea behind those products is that they are basically compatible with majority of servers which are existing today. So basically very wide compatibility with the existing install base. When those SSD drives are plugged into the existing server, they are recognized seamlessly by the majority of modern operating systems, be it Linux or Windows, and right away after installing, they could provide the benefits. And obviously, what we believe ultimately is important is that the hardware does not exist in the vacuum. In order to any technology to to provide it benefits, it is necessary to do the software enabling. And that's why what we've been focusing on in our joint collaboration with DataCore. York, if you could go to the next slide, we will cover some basic characteristics, what makes the Optane data center SSD drives different. Well, first thing I would like to note here, unlike traditional NAND-based SSDs, Intel Optane data center SSDs have the symmetric characteristics. And I'm talking about both the write speed and the read speed. In traditional NAND SSDs, you actually see that the read speed is much higher compared to the write speed. And this is again caused by the very fundamental way how the NAND cell is designed, that they are united in this string, and that's why you basically you could read data easily, but writing the data is a little bit more complicated, and you also have to do this aware leveling and garbage collection. That's why the write speed when it comes to NAND devices is much lower. The second thing is performance under load. And this is also quite important because there are certain edge use cases when something happens, like, for example, the replication. In case of the node failure in the cluster, the data becomes syncing very intensively. It kind of loads the network and also overloads the storage subsystem pretty substantially because, lots of data is being copied from one node to another. And this is exactly the case when Optane provides very high benefit, which is very tangible and easy to understand, because basically it just happens seamlessly, like in the background, and you don't see any performance degradation, because Optane is really good when it comes to performance under load. The next thing is high endurance. I will give you just couple of numbers to compare. When it comes to the parameter that we discussed already today, which is device writes per day, we typically see the range like from 1 to 3. And for high endurance drives, when it comes to NAND SSD space, the number is about 10, which is considered very high. And guess what? When it comes to Optane drives, it goes up to 60. No mistake, 6-0 compared to 1, 3, or 10 that you see in the industry, which is really cool, and this makes the setup very reliable. And again, something that Jörg mentioned already, right? Especially when it comes to hyperconverged infrastructure setups. When you have those edge remote offices, something that you would like to do is just to set and forget, right? And this is what Optane actually really provides doing. With high endurance, it kind of absorbs all the write intensity when it comes to those storage setups. And that's why it is really set and forget type of thing, rather than, needing to maintain and manage the wear out of the traditional all-flash arrays with NAND-based SSD drives. And the final thing I would like to highlight here is low latency. Again, because of the fact how the Optane technology is designed at the very fundamental level, it provides the data very quickly at very low queue depth, and that's why we see very low latency in the majority of setups. And why low latency is important? Well, simply because latency is the response time, how long we could wait. And when it comes to, typical, it could be the, let me give you an example of e-commerce store, right? In case the user is waiting for couple of seconds to complete the transaction, they just become impatient. And in case their user experience because of long wait is not good enough, we see a high number of abandoned carts and unfinished transactions when it comes to those e-commerce use cases, because the way how snappy and how fast the system is really key when it comes to user experience. And actually, in fact, there are the usability studies that proves that as soon as latency does not come the 1 second barrier, it kind of works well for the user. But as soon as user will have to wait more than 1 second, it becomes intolerable, and many people are just moving away from this product to a competitive one, which provides the better user experience. So in summary, Optane technology is unique, and it actually provides a very different set of benefits when it comes to advantages necessary in the storage space. Jörg, I think that you are next.
Yeah. Next is, if you remember, we had this slide already. It's the conversation to DRAM. We are talking about the enterprise flash. It's under time, and if we are looking for Optane, And the DRAM, we will see there's it's really close to DRAM, and so you really get a high performance. And we have one customer in Russia together, and we really see it's a customer who have heavy load time by time, and Optane really helps this customer for the heavy load. And the customer also did some tests with the flash devices, and was not the same outcome. And he's really happy with the combination between Intel Optane and DataCore. So it's really
Jörg,
what we can see. Yeah.
Let me add another point here. You know, pretty often when I talk to customers about Optane technology, it is very tempting to compare Optane SSDs directly against NAND SSDs. And maybe, you know, this is the slide that kind of provides a good illustration that those technologies are not interchangeable, right? So what we actually see is these three technologies that you see on the slide working together, providing the benefits. So this is all about being smart and, you know, taking certain right amount of DRAM, taking certain right amount of Optane SSD, and taking certain amount of flash or even HDDs in case this is necessary, in case the data is not accessed very frequently, just to make the better combination of what is available today. So this is not about displacing like enterprise flash with Optane drives. It's just using the right ratio, certain amount of flash, certain amount of Optane, and certain amount of DRAM in order to be smart and take a great advantage of latest technologies available today. And as Jörg said, you know, we are currently in the middle of, you know, economic slowdown, and people are thinking how they could get smart with the money they have, right? How do I spend maybe less, or how do I spend money wisely so that my, you know, longer term advantage is much better compared to, you know, when I use the legacy type of technology. And we actually believe that using Optane provides the smartness of combining the unique capabilities of every single technology listed on this particular slide in order to get the greater synergetic effect of both flash, Optane SSDs, and DRAM. Jörg, with that, back over to you.
Okay, great explanation. Thank you. Okay, now we come to the software side. May not all of you know DataCore, but we are the software-defined storage company. We are worldwide the leader. We have two products. We have SANsymphony. SANsymphony is for block storage. Block storage means the active data. We are talking about performance optimization. We are talking about high availability, and also we are talking about to mix different technologies on the physical side. Means you have direct access storage, you have flash inside, you have Intel Optane, you have disks, and as Alex mentioned, it's important at the moment to use the budget on a smart way, and that's the opportunity you have with SANsymphony. The other product called vFilo. It's our product for file and object storage. We are talking about to optimize the file environment your customers have. We can put existing filers together. We can provide a unified global namespace. That means we have the opportunity to optimize the file access for the customer, and also we can offload the data from an existing filer environment to get the performance back from the existing filer. That means we can combine the whole file environment and put it, maybe the unaccessible data or the archive in the cloud in a local S3 environment. Whatever the customer says, you also get a lot of flexibility. And also we have the opportunity to build an object storage for unstructured data like IoT, like digitalization. That means collect data from every sensor, from every device you have, put it in a data lake, and later on you will have access to this data and visualize the data or do some analyze with the data, whatever you like. And also you have the opportunity to have an access on file level to this object storage. That's what we can do with for the whole storage world, that means with SANsymphony, we are covering block, and with vFILO, we are covering file and object storage. So, and as Alex mentioned, to be smart, that means we need some intelligence for the data, to be smart with the budget. And we have in both products the right intelligence. In SANsymphony, it's called auto-tiering. It means SANsymphony is able on block level to put the right data on the right tier. Tier means on the right performance. That means, as example, you have a database, and this database is reading data one time a month. SANsymphony is able to select these blocks, put these blocks on the Intel Optane card for the hour the database want to read its data, and after this they put back on the SATA drive, or maybe in the cloud. It depends what you need. And the same we can do with vFILO. We are able to put files on the right storage tier, and it's simple to explain. We have the tier 1, we have tier 2, and so you are really able to combine a lot of disks, a lot of technology together. Also, you can add cloud storage in both products, and with auto-tiering, auto-placement, we are really able to put the right data at the right time on the right performance. And as I mentioned at the beginning, and maybe you remember, 10% and using 90% on the storage from the storage on IOs. And if you're thinking about it, you don't need a full flash array. What you really should think is, what are the right tiers and how I can put the right physics together to get what the customer wants to have. And as I mentioned, and also Alex mentioned, it's really important at this time to make it different for the customer, to show them, hey, here's another way. Maybe you should consider this way too, because you can save money and you are prepared for the future. That's the differentiation for you can make on your market with DataCore and Intel, or I should say on the other way, with Intel Optane and DataCore software. We did some performance testing in our lab, and with SANsymphony or in this case, and you see the difference between enterprise flash and the Optane. I'm not able to explain exactly what we did. The only thing what I know is that we would use a lot of IOPS. Alex, maybe you have some more details on the slides, or?
Yeah, sure. So we basically tested Intel Optane and Intel traditional NAND-based SSD drives in the same configuration. So what you see here on the left part of the chart, this is the graph that corresponds to 100% reads. So this is kind of the read-intensive load, right? And you see that, in this case, there is still the significant performance difference, but not that high as on the right side, where we basically see the 100% writes and 0 reads. So it kind of represents the full spectrum when it comes to those intermediate workloads. And what typically we see people are looking at is 70% reads and 30% writes. That's kind of the point number 4 at the horizontal axis. And you see that in this particular case, when the Optane drives are plugged into the system, we actually see a significant performance boost. In worst case scenario, this is about like 7.5, but on average we see like from 5x to in this particular, this is about latency. We see well, in fact, this is the same number, yeah, up to 7x difference when it comes to performance difference when Optane is plugged compared to just all flash array type of system. And on the next chart, which is basically the similar type of thing when it comes to the left side of the chart. But again, this is all related to latency. And nowadays, the lower the number is better. And you actually could see that, with 100% reads on the left part of the chart, again, the performance difference is not that significant, but as soon as you have more writes in the workload, and as a matter of fact, in real life scenario, it could be different throughout the day or throughout the life cycle of the product. We actually see very significant difference when it comes to latency. But what I would like to note here, and which is most important, is that Optane provides very low sustainable latency It basically means no matter what is happening, whether this is replication kicked in, or you have some disaster recovery scenario or whatever else, it just provides a greater level of assurance that the user experience would be good enough, would be quite good, no matter what is happening. And you see that those numbers, when it comes to vertical axis, is in fact seconds, right? So we talked about this second as the threshold when it comes to user experience, and you see that Optane provides much better user experience when it comes to this response time compared to traditional non-flash devices. But again, the whole message here is that it is important to take advantage of both technologies. Optane is not the replacement for the capacity storage. It's just a certain level in tiering hierarchy that DataCore SANsymphony software takes a great advantage thanks to its auto-tiering thing. And on the right part of the chart, you actually see the amount of time, amount of latency given the particular range. And you see that, with Optane, we are consistently on the left-hand chart simply because it provides very low latency when it comes to workloads that we tested. And we tested a range of workloads. Jörg, back to you.
Thank you very much. So how you can integrate Intel Optane in an existing or in a new SANsymphony environment. If we are talking about separate storage, I'm talking a classic SAN solution. You can add an array with Optane in it and use it together with the existing environment storage area or with the SSD or disk area. If we are talking about the hyperconvert environment, you can put a card via or an NVMe device in, so it's available in this server where it is in. And as you know, DataCore in a hyperconvert environment, you also can present this device, or you can use this device for other servers, maybe for a database server who's running on a bare metal machine. So it's also possible in a hyperconvert environment. And if we are talking about a convert environment, or you can also use it in a classic SAN environment, that means you have a DataCore server would have direct attached storage array. You can put it in as an NVMe device too, and you can use it and present data from the pool to the hypervisor on top, or to another solutions like a container solution. But the important part is in each deployment, you have the opportunity to put additional Intel Optane cards or devices in, and you can use the auto-tiering, and you will increase the performance for the right data at the right time. And that's the important part. And you don't have to invest in the full flash and the whole migration of the data and all the stuff around. So, and also, as you know, it's easy to move from one deployment to the other deployment. That means if you are on a hyperconvert deployment and you realize, well, maybe it was not a good solution for the customer, no problem. You can easily go from the hyperconvert to the convert or to the classic storage environment. That's everything is possible, and you can use the benefit from auto-tiering with Intel Optane however you like. And if we go back to the 5 points we had at the beginning, how to integrate the best way for you or for your customer, that means you can really optimize the environment for the customer, what the customer needs, and what fits in his budget too. That's also an important point at the moment. Sorry. The question is what you want to improve. It's depend from the targeting. It will be automatically. It will be dynamic. That means if there is a change in the access to the data in a half year, no worries about it. You will manage it automatically with the DataCore Auto-Tiering and the right device behind and right devices behind, and also with the Intel Optane device. What are the costs? Free choice. You can order what fits in the budget of the customer, and also you can add it in the future. That means you can start with less fast devices at the moment, and you can add a bigger device or a new device later on, maybe when from the budget from the next year or the year after. So everything is possible. You are really flexible on this part too. How to migrate? It's easy. You can do it on the business day, so will be no downtime for the migration, and also there will be no downtime in the future. That means if you add a new Optane card in the future, if you add another technology in maybe 5, 6, 7 years, I have no idea where we are writing data in 5 or 6 years. Everything is without migration. If you decided to go with DataCore, it will be your last data migration or the customer. What is with the data service? It will be enterprise class. This will be not changed. That's what we are offering. We are offering to all our customers enterprise data services. And what will be happen later? You are prepared for the future, or you are preparing your customer for the future, because everything is possible. Everything what will come, you can add to the environment. And as I told you, I'm knowing DataCore since 20 years now. And there was a lot of new technology or other technology what's coming around the corner, and everything is working with DataCore. So, and that's the really good part on it. So making your storage fast again, and to make it a little bit easier for you to convince your customer to help your customer, we will offer a special promo, Intel and DataCore. And I think, Alexei, you can tell a little bit more about the Intel Optane.
Yeah, with pleasure, Jörg. Yeah, thanks. Thanks for moving to this part. Well, what I want to say is that what is difficult is probably make the first step, right? Because we kind of get used to status quo, to the technologies which we are using today, something that is already working. And sometimes it is really difficult to go and explore something new, because you actually hear lots of salespeople, you hear lots of sales pitches, and you think that we are so confident that Optane and DataCore is the great combination that we would like to accelerate and make it sweeter for you and easier for you to make the first step, is basically to go and try yourself, right? And that's why we are running this promo, which is running until the end of the year. Well, literally speaking, this is until the December 26th, but which is almost end of the year. And the idea here is that in case you could basically buy one Optane and get the second one for free, right? And it could be the testing in the lab, or you could eventually just use this as the part of the solution that you are offering to the end customers. And with that, you actually get the free DataCore SANsymphony software. And this is, again, available for free for testing. But when it comes to new solution, which you are providing to the customer, DataCore is actually providing the free matching capacity when it comes to Optane SSDs. Basically, you get the 2 terabytes of SANsymphony with full service and support for free for 1 year, because DataCore charges per capacity per year. And we believe that this is a good offer to go out and try something new. And Optane data center SSDs is actually something very new, the new technology that, with combined with existing technologies, provide really huge tangible benefits for yourself, because this is a point to differentiate and basically highlight that you are using latest and greatest, and also for the end customers. And we believe that this is a good time for trying that. In case you have detail or you want some additional details, please don't hesitate to ask a question here in the chat, and we will be happy to provide some additional details, or reach out to us or DataCore representative later on if you need to think about it, or if you discuss it with some of your colleagues and additional things rise up. With that, Jörg, back over to you.
Yeah, thank you. And also I would like to add, if you need help on the design for a customer, please contact, I would say, me now for Eastern Europe, and I will ask one of my technical colleagues to help you with the design and to understand how you can optimize the usage of Optane or other things behind. No worries, please contact me and we will help you on the design question too. Okay, yeah, that's short summary. What I want to mention again is really also at the moment it's not easy for the companies to invest, and I think with this solution, with the Intel Optane and the software from us, software-defined storage, you can give your customer the opportunity to go in another direction, to open some new ways, some new ways for him, save money in the future, and make it easier for your customer to invest in an infrastructure project at this hard time for the whole economy on the world. I think it's the right time to go out with this promo to convince the customer. And if you need any help, please let us know. We are willing and we are able to help you. I say thank you. I say thank you to you, Alexei. You helped me out with all the technical questions, with the technical slides I am not able to cover. But if you have any question, now it's the right time to ask. I will look if there are some questions.
My pleasure, Jörg. Again, thanks for the opportunity to talk to the audience today, ladies and gentlemen. Thanks for joining, and we will be here to address any questions you might have. So please feel free to type those in the chat, and we will be addressing those one by one.
Okay, I see 3 questions at the moment. First is related to Optane. If possible, please cover details related to the limitation of combining Optane with the major server vendors.
Well, that's a good question. Let me try to address it in a way how I understood it. And if you need the correction, please provide some additional details. Unfortunately, I cannot see questions actually in the chat, maybe because of the rights. But let me try to address that. So Optane data center SSDs are provided in the industry standard 4 factors. This is either U.2 or PCI Express add-in card, which basically provides a very wide compatibility with existing servers that exist in the market today. So unlike Optane PMEM, which is persistent memory, which is very much connected to the way how memory controllers works with the memory bus, there is no such dependency in case of Optane data center drives. That's why the compatibility is really wide. So virtually any server that you could find today which has the U.2 or PCI Express slot could take advantage of Optane by simply plugging the drive into the available slot. The second thing, which is very important, is validation, right? Because typically the platform vendors do provide the do the validation when it comes to compatibility testing, OS testing, firmware testing, and so on. And that's why we see that for bigger OEM players, they are actually validating Optane, but they are selling Optane drives under their own brand, not necessarily saying that this is Optane, but basically saying that this is write-intensive SSDs. So as soon as you have you see 30 drive writes per day or 60 drive writes per day from the OEM of your choice, you could be pretty confident that this is in fact Optane drives or Optane data center SSDs, even in case they are not called Optane in the specific nomenclature of the vendor you are working with. I hope this addresses the question and I understood it correctly.
Alexei, was your question? I will unmute you and maybe you can answer if it. I hope I can unmute you. I can't. Can you try to unmute yourself? Not working. Okay. Why can't I?
Jörg, I believe that you could read out loud the second question.
Yeah, it's okay. The next question is, you will get the presentation. I can send to you around, and also you will get the recorded webinar. And yeah, Intel Optane doesn't need to be in a RAID or HA. Another question.
Yeah, could be. Could be.
Could be.
So again, it's very much dependent on reliability requirements, or availability requirements, or business continuity requirements in the particular case, right? When it comes to tiering model, there is no redundancy, right? So that's why in order to make the like highly available configuration when it comes to like at the single node level, it is possible to combine Optane in the RAID array. And again, as soon as this is a PCI Express device, it is necessary to have the PCI Express RAID controller. Or in case the platform is capable, you could also use Intel technology called Intel VROC, which is virtual RAID on chip, which is basically the PCI Express RAID, which is embedded into the latest generation of the CPU. Again, very much dependent on the type of platforms that you are using. And after that, as soon as you have two drives, you could combine them into the RAID array, or in case this is more drives, you could build another type of RAID. So this is absolutely doable, and this is again very dependent on what are the requirements when it comes to availability, resiliency, and redundancy. When it comes to high availability type of setup, it is also possible to take advantage of DataCore SANsymphony software to make the dual node highly available cluster. And in this case, you could actually have one drive in each node. So that's kind of another combination. But ultimately, this is all defined by the end customer requirements in the specific setup. I hope this answers the question.
Okay, thank you very much. I don't see more questions. Yeah, it's answered the question. Thanks. Okay, then we can close the webinar. If you have future questions, please contact us. We will answer the question. We will help you. And I say thank you to you, Alexei. It was a pleasure to have this webinar together with you. And I wish you everybody a good day, a good week, and thank you very much.
Likewise. Thank you very much. Thanks for your time, ladies and gentlemen, and thanks for inviting me for this webinar. Have a good one.